The iron and steel industry is responsible for 7% of the world's CO2 emissions. Carbon in the form of coal and coke is a requirement for the production of steel from iron ore through the blast furnace route, which is the current technology basis for the global steel production. Carbon capture and storage can significantly reduce the CO2 footprint of the iron and steel industry by sequestering CO2 instead of releasing it to the environment. Additionally, captured CO2 can serve as a feedstock for the production of commodity chemicals. CO2 is thus transformed from a waste to a product. The European Commission project FReSMe has been launched to demonstrate the feasibility of valorizing both CO2 and hydrogen capture from blast furnace gases by turning them into methanol, a versatile platform chemical and renewable fuel. The production of methanol from CO2 offers the unique combination of scale, efficiency and economic value necessary to achieve large-scale carbon reduction targets in Europe. The project relies on existing equipment from two Horizon 2020 projects, stepwise that enhances CO2 separation from blast furnace gases, and MEF-CO2 that demonstrates methanol synthesis from CO2 in different operational conditions. To demonstrate the benefits of this alternative fuel, we are going to travel north and set off on a ship between Sweden and Germany, the Stena Germanica. In the quest to meet new regulations in the maritime sector, ships across Europe are being adapted to run on eco-friendly fuels. Retrofitting vessels to run on methanol has a significantly lower cost than adapting them for alternatives such as natural gas, making the green fuel generated by FReSMe's technology an ideal option going forward. We envisage the daily production of 2,500 kilograms of methanol through a conversion of approximately 3,500 kilograms of CO2 per day, which in a year is equivalent to the emissions per passenger of a ferry going around the world 250 times. FReSMe, making the conversion of residual steel gases to methanol a reality.